INDIGO A1 is a comprehensive application tailored for managing both amateur and professional astrophotography setups. At its core, it serves as a user interface compatible with external as well as built-in INDIGO servers. Designed with versatility in mind, it ensures seamless multi-platform functionality across macOS, iPadOS, and iOS, providing a unified experience for astrophotography enthusiasts regardless of their device choice. INDIGO A1 presents a streamlined interface arranged in a 3-column layout without any open tabs. The layout is organized as follows. The leftmost column or the navigation pane displays a hierarchical structure of available INDIGO services along with some shared top-level features, serving as the primary navigation tool within the application. The middle column or the master pane shows the agent or feature currently selected in the navigation pane. It typically presents a structured list of the main controls for the selected agent or feature, facilitating user interaction and control, and in the rightmost column or the detail pane shows additional information or controls related to the agent or feature selected in the navigation pane, tailored to its current state. This pane may also include a log pane that captures and displays messages generated by both INDIGO and the application itself. To enhance user experience and interface customization, INDIGO A1 allows for the toggling of both the navigation and log panes. Both the navigation pane and the log pane can be concealed or revealed by clicking on the toolbar button. This design ensures a flexible and user-friendly environment, accommodating different user preferences and workspace requirements. In the Applications menu, users have the option to open additional windows that display the same system hierarchy but operate independently from one another. For users who prefer a more consolidated view, the application supports the use of multiple tabs within a single window. To utilize this feature, first enable the tab bar. New tabs can then be added by clicking the sign located in the top right corner of the window. The interface of each pane is equipped with a toolbar, which may be located at the top, bottom, or both positions of the pane. The toolbar buttons come in various types, each designed for specific interactions. State control buttons highlighted in an accented color when active control the state of a feature or function. Long operation buttons highlighted during an operation. These buttons initiate tasks that take some time to complete. And immediate action buttons which execute their assigned function instantly upon being clicked, without any color change to indicate activation. Toolbars provide tooltips for each button when hovered over with a mouse pointer, and some buttons are also associated with keyboard shortcuts for quick access. The gear icon button is a common feature across nearly all panes, offering a toggle between the main view and a preferences view. The preferences view allows users to adjust settings that influence the contents of the main view, with these adjustments being saved on either an application-wide or per-agent basis. The wrench and screwdriver icon button appears on panes that represent a device, such as an agent or server, and toggles between the main view and a raw view. The raw view provides a control panel-like interface for accessing less commonly used features not presented in the main view, catering to more advanced or specific user needs. The navigation pane within the application provides a structured view of the available INDIGO services, including server instances and their associated agents. Additionally, it encompasses control panel, serial port, and help sections for comprehensive management and support. The hierarchy is intuitively organized with icons preceding each service name to denote the type of service, where House icon indicates built-in service, Bonjour icon automatically discovered service, and Link icon manually configured services. Agent items within this hierarchy are also marked with a traffic light icon adjacent to their names. This icon reflects the agent's current status based on its process property, gray for idle, orange for busy, and red for an error state. In the preference view of the navigation pane, users are presented with several control options for customization and optimization. Disable Bonjour Discovery option turns off the application's built-in Bonjour client, necessitating that all services be manually added. It is useful for users who prefer or need to manually manage their service discovery. Hide controls options allow users to declutter the navigation pane by hiding specific items, making it easier to navigate and focus on frequently used services or agents. Use GPU acceleration options toggles off switches image processing tasks from GPU to CPU. This is not recommended unless necessary, as GPU acceleration significantly enhances performance. Users unsure about this option are advised to leave it enabled. Manually configured services list for users connecting to legacy INDIGO-based servers or servers outside the local network. This list facilitates the addition and management of such services. The log pane is a feature for monitoring and analyzing the activities and events within the software, providing real-time feedback on operations at a granularity determined by the user by setting the verbosity level. The levels are error for critical issues, information for general operational messages, and more messages for a detailed insight into the software's processes. It's important to note that the settings and verbosity level of the log pane are independent of the logging settings for any built-in or remote INDIGO server. The log pane also offers the option to enable audible alerts via the bell icon button and spoken messages through the voice icon button. These features enhance accessibility and real-time monitoring, alerting users to important events or changes even when they are not actively looking at the screen. Users can insert bookmarks into the log, save the log for future reference or analysis, or to clear the log and free up space. The control panel within the application displays the INDIGO hierarchy, organizing services, devices, property groups, and properties within the master pane, and specific property items within the detail pane. These properties are designed to interact with the user in various ways, being either writable or read-only, and are categorized into 5 distinct types. Text vectors comprised of text type items. These are displayed as a list of text boxes for user input. Number vectors contain floating number type items, complete with minimum, maximum, and step values, alongside presentation formats. They are shown as pairs of values representing the target and current values, allowing for precise control and monitoring. Switch vectors made up of Boolean type items. Switch vectors come with associated behaviors: select one, select at least one, select any, and are represented as checkboxes for straightforward interaction. Light vectors include items of state type, idle, OK, busy, or alert, and are visualized as traffic lights, providing an intuitive status indicator. Blob vectors consisting of blob-type items. These are presented as image previews with options to save or upload, facilitating the management of binary large objects. Reset and commit buttons appear when the value of a text or number item is modified, allowing users to either revert or apply changes. Set property button is always available for specific number properties, enabling users to set properties even without changing the target item. Blob download button is present for blob properties to facilitate the downloading of data, a feature that is disabled by default for inactive blob properties to optimize performance. Additional controls are available for certain properties, enriching the user experience. For example, equatorial coordinates feature a target query field for object selection from local or Simbad catalogs, and geographical coordinates offer an address query field for precise location selection. The raw device view mirrors the control panel in functionality, showcasing only the property groups and properties hierarchy for a simplified interaction model. The serial ports view is designed to streamline the management of devices equipped with a serial port or URL property. Within this view, users can select from available serial ports for each device or opt to enter a connection URL manually. To enhance user convenience, all modifications made in this view are automatically saved, ensuring that settings persist across sessions. This view integrates a dynamic list that showcases available serial ports, derived directly from a specific device property. However, it's important to note that this list is not updated in real time. Consequently, if a new serial over USB device is connected, users may find it necessary to manually refresh the list to accurately reflect the current state of available ports. This manual refresh feature is crucial for maintaining an up-to-date overview of connection options, especially in environments where devices are frequently added or removed. Look at Basic Concepts chapter in the Help section to learn more. The Imager agent is tasked with capturing single images or batches of images, videos, and calibration frames. To accomplish this, it oversees the operation of the main camera, the filter wheel, and the focuser devices. The master view features user interface controls for these devices, as well as for managing image batches and associated agents. The detail pane displays the captured image, augmented with pertinent information such as histograms or point spread functions, alongside details regarding the batch and the status of the devices. The camera control group begins with a camera selector, which lists all the devices available for use by the agent. Once the device is chosen, additional controls become accessible. The same applies for the focuser and the wheel group. The lower side toolbar may contain the following buttons initiating distinct agent processes. Capture a single frame in preview mode using the current settings, without saving the image. Initiate an infinite loop that captures frames in preview mode with the current settings. Capture a batch of frames according to the current settings and saves them to a folder chosen by the user. Capture video in preview mode using the current settings in an infinite loop, without saving the video. Capture video with the current settings and saves it to a folder selected by the user. Initiate the autofocus routine. This option is available if the Hide Autofocus Group option is not enabled in the preference view. Move the focuser in or out as long as the button is pressed. This option is visible if the Hide Autofocus Group option is enabled in the preference view and focuser steps per click is set to 0. Move the focuser in or out for a specified number of steps. This option is available if the Hide Autofocus Group option is enabled in the preference view and focuser steps per click is set to a non-zero value. Pause or resumes the current capture process. Abort the ongoing capture or autofocus process. The Master Pane Preference View offers a suite of configurable options designed to tailor the user interface and functionality to specific needs and preferences. Use sliders determines whether sliders are displayed for adjusting numeric field values, providing a more intuitive interface for fine-tuning settings. Use server-side preview decides where the preview image processing, stretching, should occur either on the server or client side. This is particularly useful for remote server setups with limited network bandwidth. Selection of the camera driver's output image format. FITS is the most commonly used format due to its widespread support in astronomy software. Selection of the camera driver's output video stream format produced by the camera driver. AVI streams encapsulate JPEG frames within the video container, whereas SER streams contain uncompressed RAW frames, affecting quality and file size. Hide controls options allow users to declutter the master pane by hiding specific items, making it easier to navigate and focus on frequently used features. Don't link local agents manages whether the agent should automatically cooperate with Astrometry, Guider, and Mount agents. This option should be modified only with a clear understanding of its impact, as it affects how integrated the system is. The detail pane in its main view serves as a dynamic display area for the most recently captured image, if available. The presentation of this image can be enhanced with additional data through 4 types of overlay panels, each offering specific insights into the image or the imaging process. The availability and content of these overlays depend on the user's current preference settings. Histogram overlay presents the image's histogram, a graphical representation of the distribution of pixel values across the image. For raw or grayscale images, the histogram and basic image statistics, such as the minimum, maximum, average, and median pixel values, are displayed in a single column. For color images, these statistics are presented in 3 columns, corresponding to the color values. Point spread function, PSF, overlay provides detailed statistics about the point spread function, including the full width at half maximum, FWHM, half flux diameter, HFD, and peak value. It also shows a zoomed-in detail of the currently selected star and, optionally, the history of PSF statistics. Progress overlay displays the status of the current exposure and ongoing batch processes. It provides real-time feedback on the progress of image captures, allowing the user to monitor the advancement of their imaging session. Info overlay reveals the current state of critical equipment and settings, such as the cooler's status, the focuser's position, and the current frame rate. The upper side toolbar features an array of buttons designed to enhance and control the visualization of images, from left to right as follows: highlights oversaturated pixels in raw images, applies slight, moderate, normal or hard stretch, shows magnified views of the image's corners, zooms in, out, to full resolution and to fit, flips image horizontally and vertically, centers zoomed image on selected star and sets subframe to the selection. The Detail Pane Preference View is structured to offer customizable settings, enabling users to adjust the user interface and functionality according to their individual requirements. Look at Capturing Images chapter in the Help section to learn more. The role of the guider agent is to ensure the mount stability during the main camera's long exposure periods, a process known as guiding, and to make slight adjustments to the mount's position between exposures, a technique referred to as dithering. To accomplish these tasks, it operates both the guiding camera and the guiding device. The guiding device can be connected through various methods, including the guider port on the guiding camera, the guider port on the mount, or directly to the mount controller. The camera control group begins with a camera selector, which lists all the devices available for use by the agent. Once the device is chosen, additional controls become accessible. The same applies for the focuser and the guider group. The Drift Detection Control Group encompasses settings for the algorithm responsible for identifying stars and tracking their movements. The Drift Correction Control Group comprises configurations for the proportional integral controller algorithm designed to adjust for drift. The Dithering Control Group contains the parameters governing the dithering algorithm. The lower side toolbar may contain the following buttons initiating distinct agent processes. Capture a single frame in preview mode using the current settings. Initiate an infinite loop that captures frames in preview mode with the current settings. Starts the calibration process. Starts the guiding process. Save guiding logs. Aborts the ongoing capture, calibration, or guiding process. The detail pane for the guider agent is very similar to that for Imager agent. The only difference is that the progress and info overlays are replaced by drift and correction graphs overlay, which shows the historical data of measured errors and the corresponding corrective actions taken, presented in both circular and linear formats. The content may differ depending on whether equatorial, in arcseconds, or horizontal, in pixels, coordinates are used. Look at Guiding chapter in the Help section to learn more. The mount agent serves as the intermediary between the user and the mount or mount controller, domes, field rotators, and GPS units, facilitating navigation to various celestial targets in the night sky. It displays the mount's target position on the star map, enhancing the user's ability to track and locate objects. Additionally, the mount agent oversees access to both built-in and external object catalogs, providing a comprehensive resource for identifying and selecting astronomical objects to observe. The mount control group begins with a mount selector, which lists all the devices available for use by the agent. Once the device is chosen, additional controls become accessible. The same applies for the dome, field rotator, or GPS unit groups. Target Controls Group is designed to facilitate the pointing of the mount either through direct coordinate input or by selecting a target from a search result. Observatory Controls Group contains the geographical coordinates of the observatory, which can be entered either manually or by address geolocation query. The lower side toolbar may contain the following buttons initiating distinct agent processes. Initiates the movement of the mount to the coordinates specified in the target J2KRA/DEC fields. Aligns, synchronizes, the mount's current position with the target J2KRA/DEC coordinates, effectively calibrating the mount's pointing accuracy. ES the mount to a predefined or user-configured parking or home position. Toggles the mount tracking state. Rotates the field rotator clockwise or counterclockwise, respectively, by a predetermined step size. Toggles the built-in LX200 server on or off, allowing the mount to be controlled remotely by an external planetarium, enhancing the flexibility and integration with other astronomical tools. Instantly stops all ongoing movements of the mount. The Master Pane Preference View offers, among controls known from another agents, a control forcing the mount using the King's rate instead of the sidereal tracking rate. Master Pane shows the star map for both showing the current position and FOV size and orientation and to selecting the target for slew or sync operations by a mouse click. Also, a selected target overlay can be shown. Manual Movement Control Overlay provides hands-on access to mount controls for direct manipulation. The upper side toolbar features an array of buttons designed to customize the visualization of the map, from left to right as follows: rotate the star map clockwise or counterclockwise by 15 degrees, zoom the star map in or out, centers the star map on the coordinates pointed by the mount, centers the star map on the coordinates of the selected target and cycles between more and less stars shown on the star map. The Detail Pane Preference View is structured to offer customizable settings, enabling users to adjust the user interface and functionality according to their individual requirements. Look at Controlling Mount chapter in the Help section to learn more. The auxiliary agent is designed to manage up to 4 auxiliary devices efficiently. The specific properties available depend on the device and may include, for example, a list of ports, heaters, and weather information, etc. Look at Controlling Auxiliary Devices chapter in the Help section to learn more. The Astrometry agent, or an equivalent plate solver agent, is designed to seamlessly interface with the local Astrometry.net framework or another compatible plate solver engine. Its graphical user interface facilitates the management of engine indices and streamlines the processes of star and polar alignment and also precise slew with the associated mount agent, thereby automating these critical procedures for astronomical observation. The Solver Result Group displays the outcomes of the most recent plate solving process, encapsulating critical astrometric data. The Hints Group offers optional parameters to the plate solver engine, enhancing efficiency and accuracy in obtaining results. Precise Go-To Controls Group is designed to facilitate the precise pointing of the mount either through direct coordinate input or by selecting a target from a search result. The lower side toolbar may contain the following buttons initiating distinct agent processes. Initiate a process to capture a frame using the designated imager agent and then solve it based on the provided hints. Capture a frame with the imager agent, solve it with the provided hints, and then synchronize the telescope mount to the celestial coordinates at the center of the frame using the mount agent. Capture a frame via the imager agent, solves it using the hints, syncs the mount to the frame's center, and then slews the mount back to the original target coordinates. Execute a series of slews to a selected target with the mount agent, with each movement confirmed by solving frames captured by the imager agent. Determine and reassess the polar alignment error of the mount by solving frames captured with the Imager agent. Upload a frame to be solved with the designated hints. Instantly stop all ongoing processes, including mount movement. Look at polar and star alignment with Plate Solver chapter in the Help section to learn more. The Indigo system is designed to be user-programmable through scripts written in the ECMA script language. These scripts are run by the scripting agent, enabling users to leverage both low and high-level Indigo bindings. Additionally, the system offers a framework specifically designed to facilitate the creation of sequences, a user-friendly scripts for automating repetitive tasks. Scripts group displays a list of saved scripts. Clicking on any item in the list will open the script in a source code editor in the detail pane. By clicking on the play, you can execute the script. By clicking on the trash button to the right, you can delete the script. The same applies for sequence group and sequences. Stop button stops executing the sequence as soon as possible. Note that you can't abort running script unless it exposes the same API as sequences do. The source editor facilitates the editing of a script's source code, incorporating common functionalities such as automatic indentation and syntax coloring to enhance readability and coding efficiency. Additionally, it integrates a built-in JSLint engine to verify the script's validity, ensuring that the code adheres to established coding standards and practices for improved reliability and performance. The Sequence Block Editor provides a versatile platform for editing sequences either as a list of execution blocks with associated parameters or in the form of sequence source code. Users can easily toggle between block and source code modes by clicking the Script toolbar button. In block mode, new execution blocks can be added by clicking the Add Block toolbar button. These blocks are customizable. Users can rearrange them through drag and drop and remove them by clicking the Trash button. The editor also supports the addition of loops with a specified repeat count, which are represented by a pair of execution blocks, a loop start and loop end. These loops can be nested for complex sequence structures. Certain execution blocks interact with Indigo properties and offer a drop-down menu of choices. However, these choices become available only when the device is connected. For blocks that require selecting configurations or devices, there's a play button which allows for immediate execution of the block to load configurations or select devices. For blocks that reference file system folders, ensuring access in a sandboxed environment is made possible through the Folder button, facilitating the selection of the appropriate folder. Execution progress is visually indicated by the block semaphore light within the editor. This indicator shows whether a block has been executed, is currently in progress, has failed, or has not yet started, providing clear and immediate feedback on the sequence execution status. The visibility of toolbar buttons in the editor is dynamic, varying based on the current mode and state of the editor. The script button toggles source and block editor mode. The upload and download buttons allow to upload or download the script or sequence to or from the local file from or to the server. Commit or revert buttons commit or revert all changes of the script or sequence to the server. The Add Block button shows the menu of all available sequence execution blocks and add the selected one into sequence. The Bolt buttons toggle Execute on Agent Load and Execute on Agent Unload attribute of the script. The Folder button opens the folder browser to allow file system access in a sandboxed environment and copies the selected path into source code. The preference views of the master and detail panes shows some self-explaining options for customizing main view's behavior. Look at Using Scripts and Sequences chapter in the Help section to learn more. The configuration agent is designed for the purpose of saving and restoring the system's state. This includes a saved configuration comprising the array of loaded drivers, as well as the selection of devices in other agents, accompanied by their configuration profiles. Look at Managing Configurations chapter in the Help section to learn more. Each Indigo server includes a virtual device that serves as an interface for server management. The server info group displays the contents of the info property. The log level group is designed to control the verbosity of logging for both the server itself and the drivers executed within the server. The driver group contains a list of all available drivers. The preference view features checkboxes that allow customization of which device drivers or agents are displayed in the driver list. Look at Managing Server chapter in the Help section to learn more. To learn even more, visit our forum, Indigo Web or Indigo Project Documentation section on GitHub.